It's a great example where if you start to get comfortable with thinking strategically about the SAT, this question takes on an entirely different kind of perspective, I guess. It gives you a different perspective on how to solve things because a lot of people are just going to be like, all right, this is an equation. I've got some function notation. I got to think about how the equation works. And there is an element of just kind of like plug points into equations here. My main math strategy definitely comes to mind. I have an equation. These are essentially points. So I'll maybe show you how that might work later, but I would want to go to Desmos here to specifically use a version of plug points into equations that I call arithmetizing. We're going to basically make up a number for A. And because of my experience, I know that that's probably going to be okay, even though it seems risky, right? Like, what if A is a different number? Wouldn't that produce a different result, since it seems like the A really matters for how we find the product of these two things? So it seems like changing A would change the answer. But I know that that can't be the case, because if it were the case, then there would be lots of different answers. In fact, probably infinite answers. So I don't know what's going on in the back end of this question. There must be some sort of algebra that allows the A to basically not matter. But what that means for me now is that I can disregard it by just giving it a number, making it any number, and thinking about the question in that way. And Desmos really lets me do this by allowing me to use that slider feature. So let me show you what I'm going to do. I'm mostly just going to type exactly what I see. So let's start with the equation. So g of x is equal to, and then the absolute value that is on your keyboard, usually right above the enter sign, you have those vertical lines, the enter button, I should say, on your keyboard, but it's also right here. It's the A above the ABC, and we type x, and let's come out of it before we do the division by A. We can just type A here. We'll plug into it later, and then minus 14. And it says add a slider, so we're going to do that. We're going to make A 1 for now. I know it says it's not, but I'm just going to not tinker with it yet. But let's do the other piece. What is the product of g of 15a and g of 7a, right? So the good thing about Desmos is it really handles function notation well. So I can kind of use function notation as I enter things. So I'm just going to enter it just as they say. So g of 15a and product, you have to know means multiply. So there we go, times g of 7a. So g of 7a. And I always make sure I type everything right. Does this look good? G of 15a, g of 7a looks good. And a is 1, but we'll change that. G of x is equal to the absolute value of x over a minus 14. Cool. Now make sure you follow the instructions. They say that a has to be less than 0. So let's move this and just make it negative 1. And you can see my graph disappeared because now we've changed the shape. So I'm going to zoom out and I can see it's down here. And I can also see that I have an answer. 609 seems to be the answer. So, okay. Well, again, you might be skeptical. Is that the answer or is that an answer, right? We just made up that a is negative 1. What if a were a different number? Well, luckily, the slider lets us change that really quickly, right? So let's just make it negative 2. You can see it's still 609, right? What if it's negative 9? Still 609, right? So what happens is when we make that a different number, all the a's in the equation and in the g of 15a piece are going to be swapped in with the new number. It does that automatically so that we don't have to manually keep changing the number in all these different places. So it's really convenient for us if we are going to make up our own value. So it seems like I have enough evidence that here the number or the answer just is 609. And if I really play with that slider, right? So if I click off for a sec, I have the ability to drag it. Notice, as long as it's a negative number, 609 seems to be staying. Now, if I go into the positive numbers, for whatever reason, it becomes negative 7, and I don't really know that reason. And here's the thing, I don't really care. That's the beauty sometimes of approaching these math questions from this more strategic mindset, is you stop caring why the answer is the answer. If the numbers work, who cares, right? You got it. So that would literally be all I would do. If this were on the test, I would have been very satisfied with my approach and just moved on. But if I had a ton of time left over, let's say it was the first module and I had tons of time to check it in all sorts of ways, I might check my work by doing it the long way and not using Desmos. That way, if there is a problem with the Desmos solution, but I now try this other way, maybe I get a different answer and I can compare and kind of figure it out from there. But anytime I check my work on the SAT, I prefer to solve the question in a different way than I did it originally. Usually the original way is the efficient way, and then I'm just kind of usually doing algebra the second time around. So let's see how that would work. Let's go back to what I said originally. plug points into equations. Our main math strategy. They give you points and they give you equations, plug the points into the equations, right? So we have this function, g of x, and g of 15a is essentially at least half of a point. It's the 15a that is the x coordinate of a point. And we want to use the y coordinate to multiply then with the y coordinate of the other point, the 7a point, to get the product, right? So that's kind of what's going on is essentially here, I'll kind of put it in different terms. We have 2 points. G of 15a is this point 15a comma, let's call it, let's go with m, just have something different. And this point is 7a comma n. And essentially what they're asking us when they say product is get m times n. So that's where we want to end up, all right? So let's plug points into equations. We don't have the y coordinates, but we have the x's. So we're going to do g of 15a, and that is going to be the absolute value of 15a over a minus 14. Okay. Now, here's where this actually gets hard, right? Because if we did do this way, we'd have to think about this a being less than 0, right? It's a negative number. Okay, so what's going to happen here? If a is a negative number, then when we take the absolute value of it, essentially the a is going to become positive, right? So we have the value of a, but we don't have the negative that's going to be part of it, right? So this top piece here is positive. But this bottom piece is negative, right? Because that's not in the absolute value. So what we're supposed to realize in a very conceptual way, which I don't like, and this is why I would never do it this way without arithmetizing, I don't like this, is we're supposed to realize that the a divided by a is 1, right? But one of those a's is losing its negative while the other is keeping it. So essentially, this a in the absolute value divided by the a that's not in the absolute value is going to be negative 1, okay? Because one of the pieces will have a negative, the other part's going to lose it, so one of those negatives stays and makes the entire result negative, but the fact that the a is there kind of cancels out in the same way that 3 over 3 is 1 and 12 over 12 is 1, right? Or negative 5 over negative 5 is 1. That similar thing is happening, right? So what that means then is we're going to have 15 over, I'll put the negative 1 down here, right? Minus 14, right? So that is 15, negative 15 minus 14, and that is, and so negative 15 minus 14 is negative 19. Okay, so that is the value of m, right? That's what I plugged in the g of 15a. So now we got to do the same thing for the 7a. So g of 7a is equal to the absolute value of 7a over a minus 14. And again, the same thing's going to happen. I don't want to explain it again. If you don't understand it, then this is okay. This is why we would have used Desmos and arithmetized, is so that we don't have to understand it conceptually, that this positive number and this negative number are going to reduce to a negative 1. So if that confuses you, this is why we arithmetize. So we don't have to think conceptually about weird concepts. So what we're going to end up with here is negative 7 minus 14, which is negative 21, which is the value of n. Now coming back up here, right, we have negative 19 times negative 21. Oh, sorry, this is negative 29. See, this is why you check your work. This is negative 29. So be careful there, Mike. That matters. So negative 29 times negative 21 is 609. And that's exactly what we got. Oof, but you can see this is, I'm not going to edit out my mistake there because I did catch it. And it's a good reminder of why I don't want to do these kinds of conceptual things. Because just to think about how that a is going to behave as a negative number with this absolute value takes a lot of brain power. And as I'm thinking about that and worrying about that, you know, brain power is a finite resource. You can't use it in all these different places. If I'm using it over here, there's less to use over here. And that's literally what happened here is there's less for me to use with the basic arithmetic because I'm thinking so hard about all this other weird stuff. By arithmetizing, by just making up that number for a, we're able to remove this conceptual piece. We don't have to think about in some abstract way how the number behaves, how the equation behaves. We can see it with our eyes. We have actual numbers. And luckily, Desmos takes it even further and just does all the solving for me. So even the the negative 15 minus 14 being negative 29 piece, that Desmos is also handling in a very lazy way. So there is no chance on the SAT I'd be doing the algebra that I just showed you. I would definitely be going to Desmos. But it's always good to, give you more methods to solve, and just in case, and certainly if I were, had tons of time to check my work, I'd probably do it that way anyway. But I hope just showing it to you, you kind of come to the same conclusion I did. Desmos here, arithmetize here, much, much better than doing it by hand and thinking conceptually.